Hello students, now I am going to explain the resistors in parallel. Okay, now when do we say the resistors are connected in parallel? When each and every resistor is directly connected to the two terminals of the battery, the resistors are said to be connected in a parallel circuit. Now you see I have connected 1, 2 and 3 ammeters across 3 resistors, and then there are 3 voltmeters. This is the ammeter to measure the total current, and this is the voltmeter to measure the potential difference. Right? Now you see when conventional direction of current is positive to negative, when the current starts flowing through this circuit, you can see that the current which is coming from here at this point, it gets divided into 3 components: I1, I2, I3. Each component going to the individual resistors. Now you see that the current reading here is different and different in these ammeters, right? But you see that these voltmeters show the same voltage as shown by this voltmeter. So you can say that the current flowing through the resistors is I equal to I1 plus I2 plus I3, but all resistors are working on the same voltage, that is V1 is equal to V2 is equal to V3 and in turn equal to V. Okay. Now, using I is equal to VR from Ohm's law equation, we can say I1 is equal to V upon R1, I2 is equal to V upon R2. Similarly, I3 is equal to V upon R3. Okay. Now, substituting these values of I1, I2 and I3 in equation 1, we get V upon R is equal to V upon R1 plus V upon R2 plus V upon R3. Right? Now, in order to eliminate V from the equation, we take V common. So, V, left hand side, right hand side gets cancelled, and we get that reciprocal of the equivalent resistance of the circuit is equal to sum of reciprocals of individual resistances. Excuse me. Or reciprocal of equivalent resistance of a parallel circuit is equal to sum of reciprocal of individual resistances of n number of resistors. Okay. Now, here if each resistor out of n number of resistors is of the same value, they have equal value, let it be R, then this equation 1 upon Rp can be written as 1 upon Rp is equal to N, that is the number of resistors divided by the individual resistance. Or directly you can find out equivalent resistance of the parallel circuit is equal to individual resistance divided by the number of resistors, right? Or you don't want to find the reciprocal, so directly you can find Rp is equal to R1 multiplied by R2 divided by R1 plus R2. But this is to be used when the resistors are not of equal values. Okay. Now look at this circuit. Now this circuit, there are 3 different pathways for the flow of current. So you can use the resistor of your own choice. If you want to switch on any individual resistance, you can do so, but rest of the resistors will work. Another advantage of using this circuit, this is the circuit we use at our homes, that all the appliances work at same voltage. You know, we get voltage at 220 volts. So all the appliances which we get in our homes are designed to work at 220 volt. So in the parallel circuit, you can use appliance of your own choice. All appliances work at same voltage, and very important, the total resistance of the circuit becomes very low. The total resistance of a parallel circuit is lesser than the least resistance in the circuit. I hope you understood this topic. Thank you so much.